ever noticed AI that works great in English, but not so much in the other languages? If you have felt that gap, you're not alone. And today we're diving into why multilingual AI still has a long way to go. Welcome to the Women in AI Research podcast, the show about remarkable contributions of female researchers around the globe. I'm your host, Jekaterina. And now let's dive into your research. You're doing research on language diversity and multilingual AI. So, what do you see as the biggest challenge in evaluating multilingual language models today?
Yeah, so there are quite a few. There are a few multilingual language models out there. I think they're slowly adding different languages. They're trying to cover 200 to 500 languages, and they're doing it by curating and collecting data sets that are high quality from annotators and injecting them, like including them into the model, which is very encouraging to see. I think in terms of the evaluation, the most difficult part again is the very simple thing is like the lack of data benchmarks. So anytime a new language gets included, because it's a long tail problem, right? You have your popular languages that is profitable for large companies to cover. Then there's a long tail of thousands of languages, and then even longer tails of dialects without written text or variations of vernaculars. So it's a matter of like how much data there is, and every time a new data set or benchmark gets included, it definitely gains a lot more attention from researchers and users being able to use that benchmark data set. Yeah, so that is one thing. Another thing is that English is always going to be the focal point. It's and so I think most corporations and technology companies would focus on English first versus everything else, which makes sense. But also English must never perform worse when you are creating a model. So that is a essential criteria. So that is a English focus point when you're creating multilingual models. So then maybe there's this argument for creating regional models instead for regions that do not predominantly speak English, rather than just having a huge multilingual model. Most models think in English, so there's that issue. Another important thing that we wanted to sort of share with the community in our foundational paper on low resource language translation is, the four important aspects to get across. So one is creating new data sets, and two is having these open toolkits and models. The world language database is very important for the community to share, but also having your parsers and taggers for your language, or even OCR for your language. Community collaborations are very important, like Massacane, C-Crowd, America's NLI, and then regional opportunities in funding and grants to the regions for collecting data. That is also incredibly important.
Okay, yeah, and then building on that first point that you mentioned about the long tail of languages. I know that you have that new paper on SIB 200 dataset.
Yes.
And in that work, you provide a topic classification benchmark for over 200 languages and dialects. And for many of these languages, that was the first publicly available evaluation data set for
Yes.
natural language understanding, right? So could you tell us a little bit about your motivation for this work, and also how you approach creation of such a massive multilingual benchmark?
Right. Right. Yeah. So a lot of times when you're annotating from English, especially with translation. So this is So from SIP 200, what we did is we took the Flores dataset, which is multi-way parallel translations of 200 plus 2 languages. The additional 2 is in Flores Plus. Um, and so it's a multi-way parallel translations from English. So already you can see that like from a multilingual, multicultural perspective, everything is always rooted back in English. But anyway, back to this work. So in this work, what we did is we took those sentences and then we further classify those sentences to create a natural language understanding, like an entailment data set from English. And we can talk about the challenges of that's starting to come up with multilingual, multicultural work later. So that's what we did. Um, and from there, we were able to um, run the data, benchmark the data set on various models, and then explore the language families and the regional differences. And for sure, we start to see that even though it's the same data set for every language, it performed much worse for African languages, South American languages, and much better, of course, for English, European scripts, European languages. So we definitely saw that there were regional differences there based on this benchmark data set.
Hmm. Yeah, it reminds me of one of our previous episodes as well, where Vered Schwartz was speaking about regional differences
Yes.
across AI systems, and she
Mm,
mentioned that like that geographical distance based metrics are well, not always correctly represent the diversity of languages because, let's say, US and Australia are very
mhm, mhm.
distant in terms of like actual physical distance, but the
Yes.
cultures are probably way closer to each other than, let's say,
Yeah.
US and
So
one of the African.
yeah, so that's the exciting part. I actually wanted to talk about one of the work we did, which is the World Languages Database that we've been working on, I think, the past 2, 3 years. And this was a database built by CMU rather quickly. And then they published a paper. And now researchers, computer scientists who come from the language model world, who are not steeped in linguistics, they use the database assuming that is perfect and correct. And then that the language vector they used it as like a math vector, right? Like just added up with cosine similarity. So we did a reproducibility evaluation on the database, and we found that is the imputation method might not be right. There's missing data, there's missing languages, there's missing features. And so we actually went and we've submitted 2 papers and published one so far on how to make this database stronger. So now it's called a Uriel Plus, because the original database is called Uriel, and we made it into Uriel Plus. So we gave it different distance metrics that you can use, and geographical is one of them. But we recalculate the English distribution based on the number of speakers, and then we also calculate like the language families based on their hierarchical tree structure based on the genealogy of the language. And then we also did a third distance calculation, and then we added scripts, right? How script features how a language is written, and we added more languages. So we actually did a lot of work on this database the last couple of years. So hopefully everyone will use it, and it will help in a more transparent manner. And everyone will learn a little bit about linguistics before they blindly try to use a linguistics database, or at least they have some understanding when they use this database, because there's now different options of using different distances, and now there's more features and different imputation methods for missing data.
Right. That's great to hear about that because it's not just about the new artifact, like the new data set, but it's also that you have introduced those additional new metrics, right? That
Yes.
everyone could use to evaluate their own, let's say, data set.
Yeah, it's I feel like we're doing important basic work on making this database better for the community to use, especially for people working on language diversity and multilinguality. I think a lot of people will come across this database and, maybe they want to choose a pivot language, and like this is the pivot language they should use. We also,
Right.
so we did data. So we added more data. We improved the calculations of distances, and then we added a benchmark suite so that for anyone who's adding on top of it, or for ourselves when we're making improvements, we can always go back and benchmark and know whether we're doing better or worse. So it's not like blindly creating a database. It's creating a database, then having a world languages database for the community to use, and then have some sort of a baseline saying this is how much we're doing better or worse, and is very transparent.
Right. That sounds like a super important and valuable new resource of information, metrics, and data. Amazing. And thanks for working on that. Um, I want to quickly come back to the SIP 200 work
Hmm.
and mention that you in that work you have found that simply scaling the number of languages in pre-training without scaling up the domains isn't that helpful. Can you elaborate a little bit on that point and
Right.
tell how it can help with building multilingual models?
Ah, right. So yeah, so before we started working on SIP 200, 500, sorry, SIP 200, we were doing some similar to benchmarking, but we were looking at different factors that goes into training a model for different languages. And the central question, the research question we wanted to know is, okay, we have a model that we're going to train. What should we be spending our limited resource on? Right? Like every language would like to have a model for themselves, but should they be collecting unsupervised data for pre-training? Should they be collecting supervised data for labeling? Should they be collecting domain specific data? What should they be spending time on? So we came up with 5 different data dependent factors. So amount of pre-training data, amount of fine-tuning data, whether the data was noisy or clean, um, the domain similarity of the data, and then the language similarity. Maybe we can use, instead of English, we can use Spanish or French, or instead of Hindi, we can use something similar in the Indic family, maybe like Punjabi. So those were the research questions and the variables we looked at. So we did some preliminary experiments, holding some variables fixed and then varying the other ones. And then we did a mathematical analysis of which factors is most important. And it turns out pre-training doesn't get a little bit of data in pre. You really need a lot of data for pre-training to work, to build a model for that language. So nowadays you really have to settle on fine tuning, which is like taking that little bit of multilingual data and then fine tune the model on top of it. And you can use like different parameter efficient methods, adapters, QLoRa, to fine tune your model. And then another thing we found that was very critical was domain similarity. It was very, very important for the data that you are fine tuning is exactly in the domain that you're working on. That is something that is the most important, and you should spend the most time in collecting your data on. And then language, it didn't work for us just because of the reproducibility issues that I talked about in the World Languages database.
Hmm. Yeah, right. That's very interesting. Um, let's move to a different work that you have done on multilingual models,
Hmm.
which is called MR3.
Hmm.
And that's a multilingual version of R3,
Hmm.
a rubric agnostic reward reasoning model that in MR3 is trained on 72 languages, and it achieves the broadest language coverage in reward modeling to date. Can you give us a little bit of introduction on what's motivated this work and like the brief overview of what this work accomplishes?
Right. So I really have to give all the credit of this work to my collaborators, which is Deva Anugraha, who is currently a master's student at Stanford, and Jenta Winatra, who is working at Capital One in their research team. They're both prolific researchers doing a lot of exciting work in multilinguality, especially in the Southeast Asian crowd community. So it started off, I think the history and the story behind it is that David and Genta worked on a rubric agnostic um, metric for the WMT 2024 competition last year, and they quickly came in first place. And because all of us, we work on multilinguality, it's a topic that we are passionate about. One of the most important things for us to do next was to scale this metric up into multilinguality. So the idea is that we want to, find evaluations using LM judges. Um, and, these metrics and evaluations and LMs, they work well. As always, they work well for English. And that is true for all language technology and everything in research in general. But when you bring it to you know, other languages and then moving down to medium resource languages, low resource languages, they just do not generalize as well afterwards. And that was also true that when we were doing our translation work um, on multilingual translation, the traditional metrics like BLE didn't work well for non-English. So we had to move to piecewise BLE and character F plus, and just different metrics for a multilingual context. And that was something that one of the students worked on, was exploring all the different metrics and seeing which one actually um, worked realistically for the different languages that we were looking at.
Mm-hmm.
Um, and that work was with Shravan Nayak, who is now at Mila, and Sarankika, who was a professor in New Zealand, who was in Sri Lanka during the time we did the research. So I just want to make sure we credit everyone for their excellent work. Yeah, so for this metric system, we did notice that multilingual rework research is like very, very limited. There's really not a lot of available materials out there. So we introduced a massively multilingual rubric, like an agnostic reward model. So we trained on 72 languages, and part of it was also carefully selecting the data set and the curricular learning strategy so that it performs, state of the art reward for the benchmark. And we have another paper on data collection that is coming out at AACL that shows that, by carefully selecting the most relevant languages, it was the most related languages, it actually makes a huge difference in the performance. And we also have another paper that's submitted that's on curriculum learning. But anyway, there's a lot of ongoing work, but this particular one, we benchmarked it and it actually performs incredibly well. So it seems like what worked as a award, like the David and Genta came in first place for the metric task at WMT last year, seems to also work for multilingual.
Mm-hmm. Yeah, that's interesting. And I like how you have explored over the series of work the impact of data,
Mm.
like both the initial training data set and where to put it during the training process. So it all seems to be sufficiently well explored right now with multiple studies being done on that. I'd like to ask about a different aspect, which is the model
Mm,
itself, the
yes.
model size.
Mm-hmm.
Because in this work, MR3,
Mm-hmm.
and I suspect in other works as well, you probably saw that effect that much smaller model can perform much better than the models of bigger sizes. So in MR3, for example, you surpassed the performance over the 9 times bigger GPT-OS 120 billion
Mm-hmm.
parameters model. Um, is Can you can you elaborate on the design choices that make it possible, and in general about the relationship between the model size and multilingual capabilities?
Uh,
What have you learned about that?
yeah, so I think there's definitely pushback against using the giant models and benchmarking these gigantic models and just, paying a, a very large amount of fees to benchmark these multilingual, like these low resource data sets and these data sets, these languages that have low resource in terms of data and low resource in terms of, financial capabilities and compute. So I think the idea of using smaller models is absolutely on par with this line of research versus using like a huge model, because many regions might not have the financial capabilities to fine tune billions and billions of parameters. With David Anugrahal, we also published a paper called Proxy LM. So we started off, trying to predict the performance of low resource languages for different tasks without needing lots and lots of big models, right? Without using the big models. And that led to the work of trying to predict the performance using a proxy model. So instead of using the biggest model, we found that we were able to predict performance fairly well with a smaller model. Obviously not like a vanilla transformer or small 100. And so using that work, we were able to have insights that maybe we don't have to use giant models all the time. Sometimes we do want to use small models, and small LLMs are now becoming the way to go for resource scarce scenarios. And also, even if you have a lot of resource, you do not need to use the biggest model all the time. So we do have work that benchmark the estimation, the performance prediction of using a proxy smaller model. And that came out in EMNLP 2024 findings. Uh, yeah, so we were very excited to show that
What's
work. Proxy
what's the
LL,
name of
Proxy
proxy
LLM.
one?
Yeah, Proxy LLM. So it's about using a smaller model as a proxy, as a
Mhm.
stand-in for estimating a bigger model.
Amazing,
And in the language
great.
context, so in a low resource language context. So I think all my work is the same as the NLP community, but in the specific context of considering low resource languages.
Maybe just for the audience, could you make it clear for everyone what do you mean by high resource language, medium resource language, and low resource language? What do those concepts involve?
So Joshi et al. In 2020 defined the low resource language. So we use it based on this meaning. So low resource languages is based on the scarcity of data, based on Joshi's definition. And Joshi defines it on um, the amount of unlabeled data and labeled data. So unlabeled for the pre-training and the label for the fine-tuning. Pre-training, so just, common crawl, scraped web data on the internet. And so 5 up here is your English with lots of, internet unlabeled data and lots of labeled data. So labeled data like your sentiment analysis or your name entity recognition, things that require human annotation. So all from 5 all the way down to 0. These clusters, 0 for incredibly low resource, not even any label data. And then 1, 2, 3, 4, so on. So that's the definition of low resource language based on data. There's also other considerations, but when I talk about low resource, it's always going to be based on data. But other considerations includes, not having a lot of computational resource, not having a lot of tools and models, as well as other considerations from the anthropology and social science perspective, having a writing system, the number of linguistics experts to define even the language itself, the number of surviving speakers in the community are also in consideration. So we've written a foundational survey paper on low resource language specifically for translation. So for translation is the task of translating from one language to another. And you might imagine that most of the time, one of these language pairs, either the source or the target, is English. So for our foundational paper, we categorize for the translation task. Medium resource is anything from 1 million to 500,000 based on like the 200 papers that we surveyed. 0.5 to 1 million is medium resource. 100,000 to 500,000, so 0.1 million to 0.5 million is low resource, and anything less than 100,000 sentences is considered extremely and low resource. Our follow-up paper to this, we actually found that 5,000 sentences are often enough for a translation task. And I think the following year after our paper, Meta won the best paper that says 10,000, like 5,000 is enough, but 1,000 is enough for a barely, like a very very low resource, barely resource sentence. It actually makes a difference for the data set.
Mhm. Right. And then again, a lot of your work is on the diverse set of lower resource languages.
Yes.
But there are several studies that are focusing specifically on very specific languages. I wonder what was your motivation to focus on that?
Yeah, okay. So I just want to clarify that I do work on Taiwanese Hokkien, which is my mother tongue. So I do have several
Hmm.
works in that, but I have to say that the paper is not as highly cited because these Hokkien speakers, Taiwanese Hokkien speakers are only based in Taiwan.
Hmm.
But so they don't get as much visibility as the benchmark papers that includes like 10s or 20 languages. So basically, the more
Makes
languages you
sense.
cover, the more highly cited the paper, like the more reach that paper would have. So my native tongue
Hmm.
is Taiwanese Hokkien, so not as much reach. We are collecting data sets on Chinese error translation. So it's like Comet, which identifies very fine grained errors in translation. So we're doing that for different Chinese dialects. We collect data sets for Mandarin, Cantonese, Wu Chinese, which is Shanghainese, and then and Taiwanese Hokkien, and we're hoping to cover more. It's sort of like a long-term project. We're hoping to add more and more Chinese dialect languages as we go. If it's
Hmm.
Hakka or Tai Hua or some indigenous languages in China and Taiwan, that would be really great.